Okay, here is a video just to kind of help you review some of our exponent rules to help you with some more complicated features that we'll run into later in class. First things first, when we multiply like bases, meaning 3 and 3 as those large numbers, those are called bases. When we have those numbers the same and we multiply, we will add their exponents. So the summary of this generic rule, a to the m times a to the n, is a to the m plus n. So what does that look like for us? All right, so that would be 3 to the 2 plus 4, or 3 to the 6th power. And then you could just go from there as far as simplification. Type that in your calculator or multiply it out 3 times itself 6 times. Just trying to practice some more. Y times y to the 4th times y to the 10th is y to the 4 plus 10, or y to the 14th. 12 to the 3 times 12 to the 5th is 12 to the 3 plus 5, or 12 to the 8th. All right. Our summary for our general rule down here, when we divide like bases, we're going to subtract their exponents. Okay, so what that means for us in these examples, that will be 3 to the 6 minus 2. Notice that I did the top minus the bottom. Stay in that routine. Stay in that pattern. So then 6 minus 2 is 3 to the 4th. All right, y to the 10 over y to the 4th is y to the 10 minus 4, or y to the 6th. 12 to the 5th over 12 to the 3rd will be 12 to the 5 minus 3, or 12 to the 2nd. All right, now this is one we've talked about in this class, but just in case you need a refresher, 1 over a to the n is a to the negative n. And this rule, of course, is can go back and forth. So a to the negative is the same as 1 over that. And the negative doesn't tell you to multiply by something a negative number of times. That doesn't make any sense. What it's telling you to do is do the inverse. So instead of multiplying a number by itself, divide a number by itself. So a to the negative n would be divide a n times. All right, so what does that look like for us up here? Well, I'll simplify it like I had been doing. 3 to the 2 minus 6, which is 3 to the negative 4. And now I could turn that into a 1 over 3 to the 4th. Now you might be asking, why would I do that? Why would I not just leave that as 3 to the negative 4? Well, negative exponents are confusing. When we say raise something to the negative 4 power, a lot of people don't understand what that means or how to equate that. Some people might even think that that's going to be a negative number. Well, ultimately, what we want you to know is that that's dividing by 3 times 3 times 3 times 3. So you're dividing by 3 to the 4th power as opposed to multiplying by 3 4 times. All right, so just to keep that in mind. Finishing this out, y to the 4th minus 10 is y to the negative 6, which is 1 over y to the 6th power. All right, moving to our next rule. When I multiply exponents, I need to be careful. So when I raise powers to powers, so I am raising everything inside of these parentheses to that exponent, I multiply. So this is a to the m times n. Now this leads to a lot of frustration for some folks because we want to distribute anytime we can. Notice that what's in these parentheses is one term. There's no plus or minus signs. So this rule works when there's one term. When you have multiple terms, this rule does not work, as it does not apply in that scenario. But for this case, this would be 3 to the 6 times 2, which is 3 to the 12th. Y to the 3 times 4, or y to the 12th. And 12 to the 5th, and m to the 1 times 5, since there's an understood 1 right there, and an understood 1 right there. So it'd be 12 to the 1 times 5, m to the 1 times 5, which is 12 to the 5th, m to the 5th. And this, because it's a number, I can actually type that in my calculator and get a number for 12 to the 5th. I don't have to leave it as 12 to the 5th, but then m to the 5th would be what I have there. Again, we want to be aware of something like this scenario. So we want to just say that this is a to the n, b to the n. notice that even though there's a multiplication sign, that's not a plus or a minus sign, which means it's still only one term. This rule is just to remind you that everybody in those parentheses got raised to the n power, again, provided it's only one term. All right, let's do a couple of these examples together just so we can kind of see how these rules might affect us. Now, I've got some practice for you guys with exponents. So this might be a little bit more challenging, but we're going to work through a few of these examples to help you out. All right, so something like number 2 over here, I'm going to work from left to right, deal with my exponents first before I deal with just general multiplication. So this is x to the 4 times negative 3, and then all of that's going to end up getting multiplied by 2x to the 4th eventually, but I'm going to hold off on that for just a little bit. X to the 4 times negative 3 will be x to the negative 12, and then that means times 2x to the 4th. Now, I know you might have an urge right now to go ahead and put that negative 12 on the bottom. Let me encourage you not to do that and deal with negative exponents until the very end. It will make your life a little bit more difficult the earlier you introduce fractions. So let's just save that to the end. Now, we are multiplying like bases. This is an understood 1 here, and we've got x's for our like bases, so that means we're going to be able to just add their exponents when we multiply. So 1 times 2 is 2, and then x to the negative 12 times x to the 4th will be x to the negative 12 plus 4. Again, the 1 is not attached to that negative 12 exponent. The 2 is not attached to that 4 exponent. So we just multiplied those. All right, negative 12 plus 4 is negative 8, so this is 2x to the negative 8. And now I can deal with the negative exponent. Now keep in mind that 2 is not attached to that negative 8. So the 2 is going to stay up top where it's at. It's only the negative 8 and the x that have to move to make them positive. There we go. So this would be the simplified expression. All right, let's try one with division this time. So we'll try number 6 out. All right, one of the things that's important here is for me to simplify the top before I start dividing. So let's do that right away. All right, 2 times 3 is 6. Y times y to the third times y to the third would be y to the 3 plus 3. All right, and I still just got these guys on the bottom, 3x squared y to the 4th. I haven't done anything with them yet, so I'm just going to rewrite them and not mess with them. I could simplify the top further, 6x y to the 6, because 3 plus 3 is 6. And then again, I've got my bottom that has not changed. Now, what I like to do is I like to separate these into, and I'm going to write this a little bit bigger so it's easy to work with, 6x y to the 6th over 3x squared y to the 4th. And I like to divide these up so that I'm focused on just those coefficients, just my x's, and just my y's. So now, what I'd like to do is simplify as if this is, just normal 6 divided by 3. Well, 6 divided by 3 is 2 over 1, or just 2. And now I'll deal with my x's. This is an understood 1 on that x. So that's an x to the 1 minus 2. And all the results are going in the numerator. They're all going in the top. And I'll deal with those negative exponents in a bit. And then this is y to the 6 minus 4 as I continue to deal with those exponents, divide. And when you're dividing like bases, you're going to subtract. So 2 and 1 are still the same. And this is going to be x to the negative 1. 1 minus 2 is negative 1. And y to the 2nd. Now, the good news is that 2 is not attached to a negative exponent, and y squared is not a negative exponent. So those get to stay up top, 2y squared. But that x to the negative 1 is negative, so I'm going to have to do the inverse, or I'm going to have to move it wherever it's at. I have to do the opposite, so I'm going to put it on the bottom. The 1's an understood 1, so I don't need it there now that I'm going to put an x down here. But if you'd like to leave that 1, it's not mathematically incorrect. Now no more negative exponents. I have nothing else to simplify, so this would be a completely simplified example. Okay, let's do a little bit more challenging one from this last page, and let's see if we can really step it up for you. All right, let's take a look at something like number 18 here, where we've got some multiplication that's going to happen when raising powers to powers, and then we'll try to simplify further to help you with that. All right, so first things first, when we raise powers to powers, we multiply. So that's going to be x to the negative 3 times 4, and then that's still going to be multiplied by x to the 4th. So ultimately, we'll have to combine those x's on the top. I'm not doing anything with the bottom just yet. All right, x to the negative 3 times 4 is x to the negative 12, and then I'm times x to the 4th. Keep the bottom exactly as it has not changed. All right, now when I multiply the top, I have to recognize that I have the same basis. So then I have to add their exponents. That's x to the negative 12 plus 4 over 2x to the negative 3. So that's x to the negative 8. Now notice that I've just gotten this all into one x, and that helps me kind of deal with it a little bit easier. That was my goal. Bottom stays the same, so I continue to deal with that. All right, now I don't have anything on the top to reduce with the 2, so I'm going to just keep the 2 where it's at. Now, x to the negative 8 divided by x to the negative 3, that means I'm going to subtract the exponents. So that's going to look like x to the negative 8 minus negative 3, because again, I'm dividing. Don't forget about your negatives here. Again, all my results are going in the numerator, and then I'll deal with the negative exponents at the end. Minus a negative is the same as plus. So that's negative 8 plus 3 over 2. Simplify, and I get x to the negative 5 over 2. And now that I have a negative exponent, I need to go ahead and do the inverse. So that means moving it to the bottom. So that's 2 to the x to the 5th. And I don't have anything on the top, and I need a placeholder. So what's the understood thing that's been there the whole time? A 1. And that makes this a simplified expression. All right, so you can use these exponent rules to help you simplify. Again, I encourage you to separate, to keep like variables so that you can use your exponent rules, as all of our rules dealt with like bases.